This is going to be a quick video to work through the second problem on the handout what we're doing for review. So hopefully you've had a chance to try this. I'm hoping that you're looking at this just to check to make sure that you are doing the problem correctly. It starts off asking you to draw a picture of the graph of the function f of x equals x squared minus 3x. We know this is a parabola. It's a second degree polynomial. We see the x squared there, so we know it's a parabola, which means that once I plot a few points, I should have a good idea of what it looks like. If you look down, you're going to have to plot a couple points anyway, so let's just go through real quick to make sure we know how to do that. So f of 2 means 2 squared minus 3 times 2, so that's 4 minus 6 is negative 2. So I should be plotting the point 2, negative 2 on my axis. And then f of 4 is 4 squared minus 3 times 4. So that 16 minus 12 is positive 4. So the point 4, 4 is on here. Another point that's easy to plot is 0. 0 is always an easy number to plug in just because of the arithmetic. F of 0 will be 0. So that'll give me a point here. And so you can start to see, plot a few more points, you can start to see how it's going to fall out. There's nice symmetry here. Parabolas are always symmetric about their centers, and so we can kind of see from the symmetry that the center is going to be here. And so I'm going to get this nice parabola shape like that. So I don't know if that counts as carefully, but that's the best I can do. The smallest y-coordinate, again, that's something that we can take advantage of symmetry to understand. Where we find the minimum or maximum of a parabola is actually a pretty easy question. It always occurs along the axis of symmetry. So having found where the center of symmetry is for this parabola, that means that we know that the minimum in this case, but it'll always be this is called the vertex of the parabola, is always going to be on the axis of symmetry. And so the vertex here is going to be at x equals 3/2, or 1.5. And I know that because I can see that I have the same, I have the symmetry between the point 0, 0 and the point 3, 0, for example. So because these are symmetric, they have the same y-coordinate, that means that the axis of symmetry must be halfway in between. And so you can use any 2 points that are symmetric. Halfway between will be the axis of symmetry. There's your vertex. This is only working for a parabola. So parabolas are symmetric. Lots of other graphs are not, so we can't really manage this, and that's one of the things we'll be doing with our calculus tools. Anyway, so the point is, it actually asks for the smallest y-coordinate, and I've said what the x-coordinate is. So I never actually told you what the y-coordinate at that point is. I can tell you about what it is, but my graph is pretty crappy. So in order to figure out exactly what it is, I would want to calculate f of 1.5. Let me pause this for a second while I use a calculator. All right, and my calculator says that that's going to give me the y-coordinate at negative 2.25. So the coordinates of the point here on the axis of symmetry, the x-coordinate is 1.5, and the y-coordinate is negative 2.25. So that's going to be the negative 2.25 is the answer to that question. Plotting the points, these 2 points, I've already done that. Drawing the line that goes through them. Let me see if I can use a better tool for drawing. That's as good as it's going to get. The point 2, well, so it's going to be a line like this, more or less. I'm trying to hit the point 2f of 2, which is here. We found that that was 2, negative 2. So that point and that point, that's what we're trying to hit. 2f of 2 means this point on the curve, and 4f of 4 means this point on the curve. All points in the curve are going to have this form. It's going to be an x-coordinate, comma, f of that same x-coordinate. So when you see something like this, that's basically describing a point on the curve when x is 2. This is the point on the curve when x is 4. So, so anyway, so this is our this line right here, we call this a secant line. Secant line, that goes back to the Greeks when they drew a line through a circle that cut the circle twice. It was called a secant line to the circle, and so we borrow that name for a line that cuts any curve at 2 points. But it's this line. The slope of the line we know is a rise over run calculation. So this question is just rise over run between these 2 points. Change in y over change in x. So the y coordinate of this point is 4 minus the y coordinate of the other point. The y coordinate of this point is negative 2. So the change in y is 4 minus negative 2. And the change in x is 4 minus 2. Again, same thing. The x coordinate here is 4. The x coordinate here is 2. So the change in x between these 2 points is 4 minus 2. So that's 6 in the numerator, 2 in the denominator, so that's 3. So the slope of the secant line is 3. The equation of the line, well, I'm running out of room very quickly here, so let me write it down. Equation of a line, we know 2 points on the line and we know the slope of the line. So here's the form of a line equation that I like to use. I will write, extra marks. I will write y minus one of the y coordinates is equal to the slope times x minus the corresponding x coordinate. So what I have to do, this is called point slope form of a line, and what I have to know to use that is I need to know the coordinates of a point on the line, which I do. I have a couple of them I can choose from, and I need to know the slope of the line, which I already have calculated. So let me fill in an x and y coordinate that I know. The easy one to use, if I can choose, I'll use one that doesn't have a negative number in it, so I don't have to do a subtraction of a minus number. That's harder to think about. This point right here is the easier coordinates to use. This point has a y coordinate of 4, so I'll put 4 here. That's the y coordinate of this point. And then this point has an x coordinate of 4, so I put a 4 here, because that's the x coordinate of this point. I could have done the same thing with this point, use its x and y coordinates, and you should do that to check that it really is the same line. If you want to write this line in slope-intercept form, that's perfectly fine. It's certainly not necessary without having some other task that you have to do with it. But if you did want to write this in slope-intercept form, the way to do it would be to multiply out this side, so this 3 distributes through, so 3x minus 12, and then add 4 to both sides, and you'll get an equation. And so that would be fine, but also this is perfectly fine. So that's number that's number 6. The last question is one that leads us into sort of what we're doing with this, and I'll do my best to sort of draw it on here. But they could ask, what if we use the point 2f of 2 and 2.1 f of 2.1? So again, remember, this means a point on the curve when x is 2. This means a point on the curve when x is 2.1. So 2.1 and 2 are really, really close together. Right? So 2.1 might be about there. So if I put 2 points really, really close together that are both on this curve, and then I draw that line between those, okay, that gives me a different secant line. And now because the points are close together, we're going to use a secant line like that as a representation of how steep the curve is at x equals 2. That's where we're going with it. It doesn't matter right now, but that's what we're going to do. The question here, number 7, only asks us to find the slope. So the slope, again, is a rise over run calculation. The change in x is easy to write down. It's the x-coordinate of one point minus the x-coordinate of the other, and the x-coordinate is 2, and the other x-coordinate is 2.1. For the numerator, I have to know the y-coordinate that goes with 2.1. I need to know the y-coordinate that goes with 2. Now I know that second thing, right? We already figured out that f of 2 was negative 2. So that number I know. But f of 2.1 I haven't figured out yet. So you would need to figure out f of 2.1 using the equation, subtract from that f of 2, which we know is really negative 2, and then divide by the change in x. And I don't have any room to write it, but I will leave that for you to figure out. It ought to be about, just to give you an idea of the approximate answer, it'll be about 1. So it ought to be very, very close to, not very close, but it ought to be about, rounded off, it ought to be about 1, slope of 1 on the curve. So, so if you don't get 1, send me an email. Well, I can go through what you did, and we'll see why it's not right. It won't be exactly 1, but it'll be about 1. All right, that's it. Good luck.